at Betty's Corner, we're going to look at sequences as functions. So we have some vocabulary words first. So what is a sequence? It's a set of numbers in a particular order or a pattern. Okay, so for instance, here we have an example. Each term is each number. So in this one, we have 4 terms, right? 1, 2, 3, 4. Now, a sequence can be a finite sequence, meaning there's a start and an end. It's a limited number of terms. Like I said, in this one, it looks like there's 4. Or an infinite sequence that contains without end. So we have some, it's going to get started, but then that ... tells us it's going to kind of keep going on infinitely. Now, some symbols we'll use throughout the chapter is that a sub 1, that's the first term in the sequence, a sub 2 would be the second term, and so on from there. Okay, so now the first sequence we're going to look at is arithmetic. So each term is determined by adding a constant value. We call that a common difference to the previous term. So we're going to add 3, or we're going to add -4, or you could say subtract 4. It's the same thing. So the first set of questions says, is the sequence arithmetic? So from 5 to -6, we subtracted 11, or you can say you add -11, and that pattern continues. So because it's the same through each term, yes, it's arithmetic, and a -11 is the common difference. Okay, let's look at number 2. From 7 to 12, we got 5, but then from 12 to 6, we got 4. So we were adding 4. So because that's not the same, the answer there is no, it's not arithmetic. All right, so let's get a little bit further into this. We're asked here to find the next 4 terms in the sequence, and then we're going to graph it. So from 10 to 8, we can see that we went down 2. So I subtracted 2, or I added -2, and that pattern is going to continue. So we'll go to 4 to 2 to 0. Now we're going to kind of dip into that negative value, which is okay. Okay, now when we graph these, but in this sequence, this 10 is our first value, and then 8 is our second, and so on from there. Okay, so what happens is we've created an ordered pair. So our first ordered pair is going to be 110, our second ordered pair is going to be 28, and it goes from there. Okay, so to save some time, I graphed it. Over here, I plotted all these points. Now, one thing we're going to do is we are not going to connect the points. And why is that? Well, this sequence only has 7 points, right? 7 values. So that's what we have on our graph. If I were to have connected them, remember that symbol, that lines means all the points, all of them that create that line, and it goes on without end on either side. So then we would have an infinite number of points, which is not what we're talking about here. Now, one thing, when we plot these in arithmetic, it does look linear. It looks like a line, and that's because you're adding the same value every time. So that common difference is the rate of change, right? We're changing that every time, and the rate of change we know is the slope. All right, let's look at number 4. Haralda's employer offers him a pay rate of $9 per hour with a 15-cent raise every 3 months. How much will he earn per hour after 3 years? Now, this is arithmetic, so this is kind of a word problem on how things can go using the information we have. So let's start with our line. Now, our pay rate, where does he start? He starts at $9 an hour, so that's our y-intercept, right? That's always where we start. The slope is the rate of change. So that's changing at 0.15, right? 15 cents every 3 months. So my rate and slope intercept form, I have y is equal to 0.15 x plus 9. Now, the thing is with this x, we're talking about time here, but we're talking about every 3 months. He doesn't have to wait till the end of the year to get a pay raise, just every 3 months. But it's asking after 3 years. So we have to figure out how many times is that, how many times is his hourly rate going to change? Well, there's 4 changes per year, and we're talking about 3 years. So we're talking about 12 different time periods in which he's going to get a raise. So let's see what we have. That would be y is equal to 15 cents, and that's going to happen 12 times over 3 years, plus the $9 he started with. So in the end, after 3 years, Haralda's going to make $10.80 an hour. Okay? All right, let's take a look at our geometric series. Each term this time, instead of adding, we're going to be multiplying by a non-zero, meaning it can be a zero, and we call that the common ratio. Now, we can multiply by a positive number or a negative number. We have to see how things go. Okay? Is the series geometric? That's what we're asking. Now, again, sometimes it helps to work backwards. Take 54 divided by negative 18. That gives me negative 3. We keep going, and I can see that that pattern does hold true for all of them. So yes, that's geometric, and negative 3 is our constant ratio. Okay, let's look at number 6. Now, again, we could go, either left to right or right to left. I realized right away 8 times 2 is going to give me 16. That's an easy one to do in my head. And I realized that's not times 2. That actually is 1.5. So this answer right away is no, it's not geometric. All right, let's look at one more. So again, similar to what we did with arithmetic, this time we're doing next 3 terms of the geometric sequence, and then we're going to graph them. Okay, so we have from 32 to 8. That looks like we multiplied that by 1/4, and the pattern does hold true. So we're going to end up with 1/2, and then we have 1/8, and we have 1/32. Okay, so now from here, I've already plotted the points for us, and you can see it looks somewhat exponential because of the fact that we're multiplying by a positive number. So again, similar to what we did in the last example, we're not going to graph it because it's not a nice smooth curve in which all points are contained. It's just specific points. Okay, and in this case, because all the values are positive, we're going to get it kind of a nice exponential curve, but that won't always look that way if the values are going back and forth between positive and negative. Okay, thanks so much for stopping by today. Have a good day.